Now let's look into the redox question. An outflow of wastewater from a coal mine contains Fe3 plus Mn2 plus and sulfate ions. The following procedures were carried out to determine the concentrations of them. So there are three procedures where eventually we have to find the concentration of the three ions they have given. In the procedure 1, 50 cubic centimeter sample of wastewater, SO2 gas was bubbled continuously for a particular time. Then the excess SO2 gas was removed and this 50 cubic centimeter was acidified and titrated again 0.02 mole per decimeter cube KMnO4 solution. So when you see the first procedure, you can understand that SO2 is put. Then SO2 can oxidize for sulfate, no? Then something has to reduce. So in this Fe3 plus can reduce. Okay, Fe3 plus is reacting with SO2. Fe3 plus reduces for Fe2 plus and SO2 reduces, oxidizes for SO4 2 minus. Then if you balance this, it's 4H plus, 2Fe2 plus, 2Fe3 plus and 2 water. Okay, that's the balanced reaction. Then for the same procedure, they're adding KMnO4. KMnO4 is an oxidizing agent. Now what you have is Fe2 plus. Then Fe2 plus will react with MnO4 minus. Fe2 plus oxidizes for Fe3 plus. MnO4 minus reduces for Mn2 plus. So you know that this is a very common reaction. 5Fe2 plus, 8H plus, and then 4 watt. So these are the things happening in the procedure 1. So in the procedure 1, you can see that they have given the MnO4 minus concentration and volume. Then you can find the moles of MnO4 minus. So if you find the moles of MnO4 minus, you can find the moles of Fe2 plus. If you know the moles of Fe2 plus, with the stoichiometry, you can find the moles of Fe3 plus. So after knowing the moles, and you know the volume as well, you can find the concentration of Fe3 plus from procedure 1. Now let's see the reactions of procedure 2. Another 50 cubic centimeter sample of wastewater was taken and all Mn2 plus ion present in it were converted to MnO2 by a suitable process. Now all the Mn2 plus is converted to MnO2. Now what you have is MnO2. Then excess I minus and H plus were added to the solution. And it was titrated against standard sodium thiosulfate. Okay, this now sodium thiosulfate, that means S2O3 2 minus, it is reacting with I2. That means now I2 has to form. That means I minus will react with that MnO2. Okay. MnO2. Then I minus will oxidize for I2. MnO2 will reduce to Mn2 plus because Mn it is plus 4. It will reduce for plus 2. Okay. Now all the manganese is here. Okay. So if you know the moles of MnO2, then you can find it. So I am discussing the redox question. Okay. Inorganic redox question. So take out the question with you. So in the procedure 2, another 50 cubic centimeter sample of wastewater was taken and all the Mn2 plus is converted to MnO2. Now this MnO2 is reacting with I minus. I minus is converting to I2. MnO2 is converting to Mn2 plus. Now that formed I2 will react with S2O3 2 minus and form S4O6 2 minus and 2I minus. So here you will have 4H plus and 2 water. So these are the balanced reactions of procedure 2. Now in the procedure 2, they have given the amount of thiosulfate. Moles and, The moles, the concentration and the volume is given, you can find the moles. If you find the moles of thiosulfate, you can find the moles of I2. If you find the moles of I2, keep in the stoichiometry, you can find the moles of MnO2. Okay. Then if you find MnO2, then you know the manganese moles and you can find its concentration. So from procedure 1, we can find the concentration of Fe3 plus. From procedure 2, we can find the concentration of Mn2 plus. So procedure 3, it has to be obviously sulfate. We can find it. Now look at the procedure 3. So go through the question. You have the question, right? Excess barium chloride was added to another 10 cubic centimeter sample. Now here they are taking 10 cubic centimeter sample. Now earlier they took 50-50. Okay, now they are taking 10. And then they put barium chloride. Then you know that in the solution you have sulfate. Therefore, barium chloride will react with sulfate and form the barium sulfate precipitate, and 2Cl minus will come. This is the reaction. And this precipitate is 0.223 grams. 0.233 grams. Then if you know the grams, you can convert this for moles. And then now you know the volume also. So if you find the moles and the volume, you can find the concentration of sulfate. So from procedure 3, we can find the concentration of sulfate. Is the background part clear? Can you hear me? Hello, can you hear me? Are you in the session? So now we can start finding the concentrations. Now we'll start with the procedure 1. So procedure 1, they have given the KMNO4. So KMNO4, you can see that its concentration is 0.02 and the volume is 25. So moles of MnO4 minus is concentration volume. Concentration 0.02 mole per decimeter cube. So you have to put the unit, okay? I'm not putting it, but everything you have to put the unit. Now 25 into 10 power minus 3 decimeter cube. Then it would be 0.5 into 10 power minus 3 moles, okay? Then you can see that MnO4 minus to Fe2 plus ratio is 1:5. That means moles of Fe2 plus is 5 times of this. So you have to show the ratios also, okay? MnO4 minus to Fe2 plus is 1:5. For that also there's a mark. Then moles of Fe2 plus will be 0.5 into 10 power minus 3 times 5. That is 2.5 into 10 power minus 3 moles. Then now you can see that Fe3 plus to Fe2 plus ratio is 1:1. No, here 2:2 means 1:1. Therefore, moles of Fe2 plus also 2.5 into 10 power minus 3 moles. Now you know the moles of Fe2 plus and you know the volume taken, that was a 50 cubic centimeter sample. You can find the concentration of Fe2 plus. That is moles over volume. Moles is 2.5 into 10 power minus 3 times volume is 50 into 10 power minus 3. So 2.5 divided by 50. It is 5 times 0.05. Okay. Into mole per decimeter cube. 0.05 mole per decimeter cube. Is that clear? Okay, now let's go to the second one. Procedure 2. Another 50 cubic centimeter sample of wastewater was taken. Yeah, we did that, no? Now they have given the sodium thiosulfate's concentration and volume is given. Then we can find the thiosulfate moles. Okay, can do that here. So I'm not putting unit or anything, but you have to follow. You have to put the equation, substitute with units and find the answer. So thiosulfate, they have given the concentration 0.5, volume 15. So 0.5 times 15 into 10 power minus 3. So that would be 7.5 into 10 power minus 3 moles. So that is the moles of thiosulfate. Now you can say thiosulfate to I2 ratio is 2 is to 1. Then I2 moles will be half of that. Okay. Half of 7.5. 3.75 into 10 power minus 3. So that's the moles of I2. Now I2 to manganese dioxide ratio. Okay. That's 1 is to 1, right? So we did that correctly, right? Yes. Yeah. In this, now in the second procedure, they are adding excess I minus was added to the solution and it was titrated against the sodium thiosulfate. Now in the second procedure, we considered that I minus being oxidizing to I2 using MnO2. But there is another possibility as well because there is Fe3 plus in that solution also, right? We do have Fe3 plus in that. No, they did not do anything to remove the Fe3 plus. So therefore that Fe3 plus also will react with the I minus and then oxidize I minus to I2. That means this total I2 only react with sodium thiosulfate. I think we actually missed that part. Okay. Okay, now we'll add that. And Fe2 plus. Okay. Fe3 plus will go for Fe2 plus and I minus will go for I2. Okay, so it's 2 everywhere. 2, 2. Now the total I2 only react with the thiosulfate. Okay. Now we have found out the total I2. That is 3.75 into 10 power minus 3. Now we know the Fe3 plus, right? We know Fe3 plus concentration is, we found it already, 0.05 mole per decimeter cube. Okay. Now we actually found the moles of Fe3 plus, no? That was 0.5 into 10 power minus 3, right? So this is the moles of Fe3 plus. Was that the one? No, this one. So this is the moles of Fe3 plus in a 50 cubic centimeter sample, right? 2.5 into 10 power minus 3 moles. So here we have 2.5 into 10 power minus 3 moles. Okay. So now you can see this is the moles of Fe3 plus. So if you see Fe3 plus to I2 ratio, that's 1 is to 1. Therefore, moles of I2 coming from Fe3 plus is 2.5 into 10 power minus 3 moles. The total I2 you got was 3.75 into 10 power minus 3. So out of this 3.75, 2.5 is coming from the Fe3 plus reaction. So remaining I2 is coming from the reaction of manganese oxide. So that is what we have to find. So the moles of I2 coming from manganese oxide would be 3.75 minus 2.5 which came with the Fe3 plus reaction into 10 power minus 3. Then 3.75 minus 2.5. That's 1.25 into 10 to the power minus 3. So this is the I2 coming from our target reaction. So you can see that, yeah, so that's what we found now. Oh, hold on. Small stoichiometric error. So here it's not 2. It's not 2I2. Okay, it's just I2. Okay, so Fe3 plus to I2 ratio is 2 is to 1. So I2 formation will be half of this. My bad. The half of this means 1.25 into 10 power minus 3. So I2 coming from Fe3 plus reaction is 1.25 into 10 power minus 3. Okay. So then 3.75 minus 1.25. 1.25. Then answer is 2.5. Okay. Now correct. 2.5 into 10 power minus 3. So that's the moles of I2 coming from the manganese oxide. So now you can see that manganese oxide to I2 ratio is also 1 is to 1. Therefore, manganese oxide moles is 2.5 into 10 power minus 3. Okay. So in the manganese oxide, you can see 1 mole of Mn2 plus is there, no? Therefore, Mn2 plus in the solution is also 2.5 into 10 to the power minus 3. Okay. So procedure 2, we found the Mn2 plus moles. That was 2.5 into 10 power minus 3. Now you can find the concentration of Mn2 plus. So Mn2 plus concentration is equal to moles over volume. You have to write the equation. 2.5 into 10 power minus 3. It was a 50 cubic centimeter sample. Okay, 50 into 10 power minus 3. That's also 0.05 mole per decimeter cube. Now we found the second cation also, concentration of Mn2 plus, which is 0.05 mole per decimeter cube. Then now we have to go for procedure 3. In the procedure 3, that's of course very easier. Where's procedure 3? Okay, here. So first you find the moles of barium sulfate. You know the mass, no? Moles is equal to simple M over capital M, 0.233 gram over, I guess the molar mass is 233, yes. 233 gram per mole. Then it is 1 into 10 power minus 3 moles. Okay. Now you can see one barium sulfate has one sulfate, no? Therefore, moles of sulfate is also 1 into 10 power minus 3. Okay. So you have to show that ratio, okay? Barium sulfate to sulfate ratio is 1 is to 1. For that you have marks. Now you can find the sulfate concentration. So that is 1 into 10 power minus 3 moles divided by. Now here in the third step, they took a 10 cubic centimeter sample, not 50 cubic centimeter. Therefore, volume is 10. 10 times 10 power minus 3 decimeter cube. So it is 0.1. Okay. So this is a very frequent type of redox question. They give procedures and to find. Actually, this is easier. Okay, giving procedures and finding is very easier rather than those sometimes the paragraph questions are a bit difficult. But anyway, if you plan out, it's very easier. Okay, you have to plan first. And then if you plan, you can quickly do the calculation and find the answer. So sulfate concentration 0.1 mole per decimeter cube. Mn2 plus 0.05 mole per decimeter cube. 0.05 mole per decimeter is also the concentration of Fe3.